Okay, so in kinetics, it's all about reaction rate. And just in general, the concept here is A will increase as B will decrease, right? So A and B, so that's the concept that this is concentration and this is time, let's say. So just in general, understand as the reactants collide with effective collisions, they will increase in concentration. I did that backwards. The A will decrease in concentration and the B will increase, and that makes sense. If it's in equilibrium, then they flatten out. We'll talk about equilibrium next, but that's just the general concept, right? Most questions involving kinetics, if it's a multiple choice and it's not a calculation, then they might focus on this thing. They might focus on activation energy questions, effective collision questions. How do you increase effective collisions? What can we do? Increase time. Add a catalyst.
Pressure increase. No.
Depends. If it's a gas, it might. Okay.
It's a gas.
What two? Okay. What else can we do? We can crush something up. What's that mean? Increase surface area. What two things need to happen for an effective collision?
Proper orientation.
And yeah, enough energy to reach that activation barrier or overcome it, and then the proper orientation. That's like the concept. Well, I'll just say it. Those are the easy concept questions that I hope we see. Now let's get into the calculation stuff. If I give you this equation here, again, I'm just going to kind of go through, I'm looking at my notes, going through each section just briefly, and then we'll do some practice problems. So if they give you this reaction, they want the rate expression. This is good, because I haven't reviewed this in a long time. Not the rate law, the rate expression. So rate would be equal to -1/2 the change in concentration of N2O5 over the change in time. Remember, rate is always concentration with respect to time. So like molarity per second. How does the molarity change in certain number of seconds? But I'm reviewing this, just as one example, because it's important in case they ask it. They may give you a reaction and say, which of the following shows the rate expression with respect to NO2? And you have to be able to figure that out. This can be multiple choice. So rate is equal to this, but it's also equal to 1/4 times the change in concentration of NO2 over the change in time. And then rate is also equal to the change in concentration of O2 over change in time. The rate is the same. What changes is the coefficient. So what they like to do sometimes is they say, okay, the rate with respect to N2O5, I don't actually have a number written down, but let's say the rate with respect to N2O5 is 3.0 times 10 to the -4th molarity per second. So they would say, okay, that's your rate with respect to N2O5. What is the rate with respect to NO2? Right? So that's where you're setting these things equal to each other. So so essentially all of these are equal to each other. Change in concentration of NO2, change in time. So you would plug this in for the this number would go here. So it would be 1/2 times 3 times 10 to the -4 equals 1/4 times x. Then you would multiply this by 1/2, divide by 1/4. That would give you the rate with respect to this. So when I say the rate's the same, I don't mean to confuse you there. I probably did, so I apologize. What I mean is all of these expressions are equivalent to each other, so you can set them equal. The biggest thing I want to review right now is, first of all, how to just set up a rate expression. That's not something that's common. We don't talk about a lot. We talk about rate laws most of the time. This is a rate expression. This is a rate expression.
Is it
So,
-1/2?
Yeah, this isn't it. So that's back to this. Your concentration will be a negative change because your final is less than your initial. So that's why the reactants will always have a negative. The product will have a
So
positive.
you just forget it when you roll?
Yeah, because this is going to be a positive number. Because that's
So you don't write the negative on the one hand?
She's talking about your equation, your equal.
right. Well, you
equation.
can. It's just 1.5 times the. You can leave the negative, but yeah, when you get a number here, it's not negative. Yes, you just get rid of the negative. The negative is kind of like exothermic. It's just really there to show you it's being released. Or decreasing. So, yeah, you know, I feel like if I was you, I'd be confused. So let me give you another sample problem. So again, what do you do with the coefficients? It's 1/2 or 1/4 or whatever it is. You can set them equal to each other to solve for the one they're asking for. Let me just do a problem. And I know it's my wording, but whatever. I can't find all the perfect problems. So Liz and Chi-Chi deal with it. 2H2O2 yields 2H2O plus
We were
O2.
just talking about that too.
I'm giving you as many practice problems as possible.
It's not the practice problems that we need, it's the wording. Like we said yesterday, we don't know when to use the different.
All of these practice problems are the
We
wording.
get them and we don't know what we're doing.
Isn't that why you're here, to ask me?
Yes.
Okay, all right. So,
Kinetics problem.
at a particular point in reaction, H2O2, okay, so they're telling us the rate of this decomposition is 6.0 times 10 to the negative 5 molarity per second. So the question's saying this is decomposing at this rate. The question wants to know what is the rate of O2's formation. This is exactly what I was just talking about. So the rate expression would be 1/2 times the change in concentration of H2O2 over change in time. This is that number, which is equal to the change in concentration of O2 over change in time. So what we would do is we would take 6.0, where am I here? 6.0 times 10 to the negative 5, and we would plug it in for the delta T, yeah. So we would take this and we would plug it in here. So it would be 1/2 times 6.0 times 10 to the negative 5 equals x. So this here would be my x. So what I'm trying to get you to understand is any of these reactions they could give you, if they want the rate with respect to one part and they give you the rate with respect to another part, you just have to remember to put their coefficients in fraction form. So the coefficient in fraction form times the rate is how you set up these rate expressions. This one doesn't have a fraction, so it's just x. So it's really just that times 1/2. That's it. So 3 times 10 to the negative 5. That should make sense. If this is decomposing at a certain rate, this is going to be formed at 1/2 that. Because it's a 2-to-1 ratio. So if 2 of these are breaking down, at the same time one of those is being formed, this is going to be breaking down twice as fast. Right? So that number's twice the size. Alright, moving on. This is kind of small detail, but I would like you to get it right, so that's why I went over that. So now, hopefully, you got a shot. It's not like you get there tomorrow and I didn't review rate expression, they ask it and you're like, yeah, I don't remember that. So, good. Okay, so, rate laws. What is a rate law? Rate is equal to K times the concentration of A, let's say times the concentration of B. If A is to the first and B is to the first, and we did this, was it yesterday after school? The chart?
It was the other day.
It was 2 days, okay. I think I have that copied somewhere. Right there. I'm gonna hand it out and go through that again with everybody. So if this is to the first and this is to the first, what that means is, however this changes, the rate changes. If A is to the second, however this changes, this is quadrupled. And if it's to the 0, let's say b is to the 0, that means whatever this changes doesn't affect the rate. I'm going to go through that in a minute. I have the problem right there. All right, but that's what a rate law is. Typically, first order, second order, 0 order, and third order, I suppose, could be an answer to a question. In other words, if this is your rate law, that's third order. The reaction is third order because 2 plus 1 is 3. If this was a 0, it would be second order.
Oh, that's right, it's the coefficient.
Yeah. If this is to the first and that's to the first, the whole reaction is second order. If that's to the first and that's to the 0, that's going to be first order. So that's important to remember. If they give you a rate law, sometimes they just ask, what is the order of this reaction? You just add up the exponents. 1 and 0 is 1 or whatever it is. Again, I'm going to do that after I'm done my spiel here to remind you guys how to calculate that if they give you data. All right. Okay. We'll do that in a second. All right. Okay. So units on K. So again, let's say we have K times the concentration of A. Let's say this is 0. 0 order. Rate is molarity per second. So what's the unit on K if the order is 0? If this is 0, what happens to the concentration of A? It's not there. So what's the unit on this? Right. What if it's first order? So if it's rate equals K times A to the first. Anyone remember? So what is the unit on K?
And S minus 1, is it something like that?
It's close.
Oh, S minus.
S minus 1. You know, just be careful. Sometimes in these questions they'll give you minutes or hours, but kids still write seconds. Please pay attention to the question. All right, and again, we're going to do some practice problems, but pay attention to the question. So this is to the first power, all right? So that would be S to the minus 1. What if it's second order? It's M minus 1 to S minus 1.
Oh, that's.
If it's A2, B1, then it's third. That's going to be M. Do I have the? Okay, that's it. That's all I have is third. M minus 2, S minus 1. It's the M that changes. The S always stays. The time stays the same. Again, with all units, you don't need to necessarily memorize it. If you know this is molarity per seconds, you can figure this out. You can plug in this is molarity, molarity squared, molarity. You can figure out what this needs to be to cancel those out to get molarity per second. So you can always put the work in to figure it out, or you can memorize it. So best I can do is remind you, here's what they are, but again, if you plug in your molarity and you write it out, just remember to write it out, then you can figure it out. But if you want to memorize it, this is time to the -1, molarity time, molarity minus 2, time minus 1. So they add up to the order, right? First, second, and third. So if that helps, good. Okay. You guys have your equation sheets handy?
Mm-hmm.
You can go to the kinetics part.
Yeah.
Where's my test? So everyone go to the kinetics part. Where the heck is it? Oh, there it is. You only have 3 equations. Okay. Which one is for first order kinetics? Which one is for second order? I'll give you a hint. They listed on the paper in the order. First is the first one, second order is the second one. So natural log is first order and 1 over is second order. So if I give you, let's see, do I have a little, where's my cheat sheet here? Hold on. Okay. So if I give you natural log of whatever it is, A versus time versus 1 over the concentration of A versus time. How do these graphs look? This is first order, natural log, this is second. How do they look?
One's up, one's
One's up, one's
down.
down. Okay, which one's which?
So the first one's up, second one, no,
First one's down, second one's
down, and then up, yeah.
Yep. So if you want to memorize it, fine. But if you look at the equations, how do you know which one goes down? Negative k is the slope. K is the slope. So this is negative k. It's a negative slope because it's going down. This is positive k, so it's going up. That's another way to remember it looking at it. So I'm trying to give you ways to just memorize, or I'm trying to give you little tricks, things you can remember that will help trigger your memory. You don't have to just straight up memorize everything. So like the units, those negative ones, the inverse there, add up to the order. The negative on the k means it's a negative slope. Positive means positive. Okay, here I wanted to show you these though. This is another thing to remind you of. So if I gave you these 3 graphs, they're all the same? Yeah, they're all the same. Alright, so we have 3 graphs. Yeah. Concentration of A, concentration of A, concentration of A, rate, rate, rate. We have this, we have this, and we have this. Okay. What does this show? As the concentration of A changes, what happens to the rate of this reaction? Right. So let's say it's A yields B. Okay? Or actually you don't even need to really. Just think of A as a reactant in a reaction. Okay? So it could be A yields B, I guess. Alright? What happens here, as the concentration goes up, rate goes up. Is it directly proportional?
Yeah.
Yeah. Concentration of A goes up, rate goes up, not directly proportional. I didn't draw it very well, but this is not a straight line, so the slope isn't constant. Okay. So you have 0, first and second order. Kind of give it away, but which one's which?
Zero.
It's 0, 1, 2, but why? Why does it make sense that if this is 0 order, it's a flat line here? Concentration doesn't affect rate, so it's got to be 0. First order, whatever happens to this concentration, the rate changes the exact amount. This is what I said initially when I first went over rate order like 5 minutes ago. Second order is exponential. If this doubles, this quadruples. So I like to remind you that not only does it help to remember and be able to figure out the problem I'm going to show you, but also apply it to graphs, because I love to show you graphs on the multiple choice. Right? They could say, okay, given the following reaction, it was determined experimentally, it's a 0 order reaction. Which of the following graphs, shows the relationship? Which graph matches the reaction order? So that would be this if it was 0 order. Do you have to memorize these? No. You have to understand the relationship. If you understand the relationship between the order and the rate, you don't need to memorize it. The other 2 graphs, again, I don't think you need to memorize. If you look at the equation, negative k is on the first order, positive k is on the second. So there's things here that you don't have to completely memorize. That's why we are reviewing. Okay. We went way past the bell here or whatever. You guys want to take a few minute break here?
Yep.
3 minutes.
Wait, after this test, are we gonna have any more like quizzes than we do organics?
I don't know. Let's do one thing at a time. Don't worry about that. That's irrelevant right now.
That's wait, we have it final?
You have a final project.
Oh,
One day at a time. Just let's focus on today, what we're reviewing today, and focus on the test tomorrow.
I don't want to.
So if you start in your mind thinking about it, you get way overwhelmed. So one day at a time. One day at a time. I should probably end this so it's not at least a mega video here.